So yesterday we left off, we did number 33, and then we're looking at 34 with the circle, and that's about where the bell rang. So, I got a circle, and there's a triangle inscribed in the circle. And notice every single corner of the triangle is a point on the circumference of the circle. You see that? And also, guys, look at this detail, because here's a little bit of trivia that you need to know to be able to answer this question correctly. You guys see the fact that one of the legs of the triangle happens to exactly align with the diameter of the circle? Right? You guys see that? Right. Now, the fact that it's true means that this corner, which is labeled M, is always, always, always a what kind of angle? A right angle. Guys, that angle M is 90 degrees. Right? And they could have put it anywhere. They could have put corner M here, or here, or here, or here, or here, anywhere around. As long as LN is the diameter of the circle, right? Well, once that's established, you can put point M anywhere, make all different kind of triangles, but they'll all be right triangles. They will all be right triangles. Okay, you guys do that? All right. Now that you know that, you are able to answer this question. We've got angle 1/2 A here and A here, some number of degrees, and they say, what is A? Right? Now, you might possibly be able to sort of intuit the answer. Is anybody able to figure this out? Maybe even possibly without writing anything on paper? What is A? Does anybody know? 60 degrees, right? How many of you guys noticed that this also happens to be a special right triangle? It's a 30, 60, 90 triangle. You guys see that? 30, 60, 90? Okay. Because 30 degrees is half of 60 degrees. Okay. Now, if you didn't see that right away, that's okay. Maybe you need some kind of systematic way to solve this. So I'm going to say that 1/2 A plus A has to add up to how many degrees? How many degrees do all three corners of a triangle add up to? 180. 90 of those are already occupied by this right angle. That it leaves another 90 degrees to go. So that's this 90 degrees right here. Right? Is that true? I'll just say 90. That's some number of degrees. Right? So this is going to consolidate as 3/2 A is 90. Well, okay. Throw a degree sign, right? Get a unit on it. Right? Multiply both sides by 2/3. What's 2/3 of 90? 60. So 60 degrees. Okay. Now this was not multiple choice, so you had to write the answer 60. Okay. Do you guys do that? 60? 60. Of course, there's no bubble for degrees, but no, good. Okay. Just the number, not the unit. You guys got 60? Number 34 is 60. Number 35. The point 4, 3, so coordinate 4, 3, lies on the graph of the function in an xy plane. H of x is equal to 1/2 x squared minus 8. Now pause right there. Guys, if you graph that, what shape is that? Parabola, right? So 1/2 x squared, that's like a shallow parabola, and then minus A, you just scoot the whole thing down, A units. Okay? A is a constant. What is the value of A? Right? Well, they told you one of the coordinates on that curve. So let's just plug it in and solve for, at that point, what would be the one unknown, right? We say y equals 1/2 x squared minus 8. It said h of x. I'll say y, whatever. We get the point 4, 3. So when x is 4, y is equal to 3. So it would look like that, right? Is that what they're given to you? Here's the coordinate 4, 3 happens to lie on that line. Right? So there's only one value of A that would bring that all together. Okay. So guys, what's 4 squared? 16 divided by 2 is 8. As 8 minus what is equal to 3? 5. There you go. Okay, you guys got that? Or you could switch around different. Right, 5. The answer is 5. Again, not multiple choice. You had to write down the number 5. Hopefully, you wrote down the number 5. Okay. Oh yeah, winning. Number 36. An artist is creating a rectangular mural. Ooh, creative. The height of the mural is 4 meters shorter than the width. What will be the height in meters of the mural if the area is 96 square meters? Ooh, I want to draw this out. I'm going to be my own artist. So there's some height and there's some width. Right? They told you guys that the area is 96 square meters. They also told you that the height is 4 meters less than the width. So I'll just say width minus 4. Okay, just 2 conditions. Okay. Now, kind of like a couple questions ago, you might possibly be able to just brute force trial and error, get to the answer. Just think, okay, what were some combinations of numbers that have a difference of 4 and multiply to 96, right? And if that doesn't work, then you can come up with a systematic approach, right? Who sees it? What are the dimensions? What by what? What are two numbers that multiply to 96 and the difference between the two numbers is 4? What times what? Ooh. Okay, if you don't say it right away, or maybe some of you guys do, you just see if your classmates know. You're testing your classmates. Oh, who said 8 and 12? 8 and 12? All right, sure got it. 8 and 12. Guys, could that be 8 times 12? Right, 8 times 12 is 96, and 12 minus 8, or sorry, 12 minus 4 is 8, right? So here's a system of equations approach. You could say, x, or we got not x and y. Let's do h and w with that. Right? H times w is 96. I'll leave off the units or whatever. Okay. And then, well, some version of this. Here, I'll just write out what I got up there. H equals w minus 4 is one way to write it. I guess there's a few different ways to write that. Right? This could be your system of equations right here. Right. You can solve this with substitution. Now, the question was, what was the height? Let me just double check that. I think it was what's the height. Yeah, what's the height? Okay. So if you want to solve for height, you have to substitute out the w. So could w be equal to h plus 4? And then you can take that and substitute it into this top expression. So h times, and then instead of w, I'm going to say h plus 4 is 96. Distribute, h squared plus 4h, subtract over the 96 is 0. But you're kind of left with what maybe you got by trial and error from the first place, right? Which is I gotta find two numbers that the difference is 4 and they multiply to 96, some version of that. And it looks like it's going to be h plus 12 and h minus 8. You guys see that? Right, like factoring. Right. So you have to kind of figure that out anyway. Right. Now, well, interestingly, mathematically, there's two solutions from this. H could be positive 8. H could also be negative 12, because that would also solve it, right? But then you say, okay, well, realistically, can you have a negative height? Say, okay, well, no. So you toss that one out. That makes no sense. Okay. So the answer they're looking for is 8. So did you guys write down 8? 8. We're looking for 8. Right? You guys got that? The answer is 8. The height is 8 meters. All right, you guys ready for the last two questions? Yeah. All right. These last two questions both refer to this table. Since you guys read this already, I'll try to do a quick recap. There's this 3-part triathlon race. They're going to be swimming and bicycling and running. And they're telling you what is the average speed in miles per hour and what is the distance in miles. Notice they didn't explicitly give you how much time, but you could do a little bit of quick physics and you could solve for the time for each lake, right? Maybe we'll do that later, right? We got Miss McQueen is in this race. Right? They keep mentioning it over and over, something about transition periods that we're going to ignore. Sometimes SAT does that. They throw you all this extraneous red herring information you don't need. Okay? But here's the scenario. She's got a triathlon bike, which she wants to use so she can actually go at this speed for this distance. Okay? But if that triathlete bike breaks, she has to break out her slow hybrid bike. Oh, in which case, the time to complete that particular segment, the biking segment, increases by 30%. That means she's slower, right? If it takes more time, 30% more time, she's going slower. Okay? Oh, so here's the question. How many more minutes would it take? How many more minutes? Right. So they told you how much more time as a percentage. You have to turn that into like a hard number. And also don't forget, you have to translate from hours to minutes because they gave everything in terms of hours, like miles per hour, miles, right? So that'd be another. Okay, so we got to juggle a few ideas going on here. So let's figure out first how much time is it for just her triathlete bicycle. Okay. So can you guys say distance equals speed times time? Right? Oh, hey, probably know that from this class. Right? And let's rearrange this to solve for time because we have given distances and speeds. Okay? So in general, time is going to be distance divided by speed, right? If you say like, "Ooh, I know how far I have to go and how fast I'm going," that can divide those two and figure out how much time it takes to get there. Right. So the time for the triathlete bike would be, well, we know you're going 12.4 miles during the biking stage, right? So we're doing 12.4 miles for bicycling. And we're getting there at 20 miles per hour. Right? Now, good idea to keep track of what units. So don't just think about numbers, think about units. Right? Since you guys are sitting in a physics class, right, this is a point that I emphasize all the time too. Right? So you guys know how you're measuring this time. Okay? So it's 0.62 hours. Right? Now, keep in mind too, the question was framed in terms of minutes. They want to know how many minutes. At some point, we're going to have to translate to minutes. I may as well do that here. So time for triathlete bike is, 0.62 hours. Right. But I'm going to railroad track this thing. 1 hour is 60 minutes to convert this into minutes. So times 60, right. Looking at 37.2 minutes. Right. Now, they said the time with the hybrid bike is 30% more than that. Right? So, guys, to get the time for the hybrid bike, you're going to take the triathlete bike time in minutes, right, and multiply by what? Guys, how do you increase something by 30%? You multiply by what? 1.3. Yeah, 1.30, you could say. Aha. Right. So that's like 48.36 minutes. Right? Right. So here's the time for a triathlete bike. Here's the time hybrid bike. Right? Can you guys therefore say the difference in time is well, you just subtract the two, right? That's what the difference is. 48.36 minus 37.2. Right? That's 11.16 minutes. Okay? Right? So she's slower by that many minutes. You guys got that? Right. Now, one last detail. Let's go back to the question. Because you got to read these real close. Oh, they even put this in parentheses. Oh, that's not even fair. They said round your answer to the nearest minute. So what number are they looking for on your paper? 11. 11. Hopefully you wrote 11. If you wrote 11, that's what they're looking for, right? They're not giving credit for anything else, right? Okay, guys, good? Last question. At one sprint triathlon, Miss McQueen completed the course in 75 minutes. All right. What was her average speed in miles per hour? Ooh, right? Average speed in miles per hour. So you guys know, from this class, if nowhere else, that average speed, that could be average speed right there. Isn't that total distance over total time? Right? Total distance over total time. So let's figure out what is the total distance. I got 0.25 miles plus 12.4 miles plus 3.1 miles. Right? So there's the entire race. We're going to do that entire race. Right? And in 75 minutes. 75 minutes. Right. Now, guys, if I pop that into my calculator right there, is that going to give me the answer that's going to earn the credit for the SAT? No. Why? What's wrong with that?
It can't be an equation.
Huh? What's wrong with that? Well, here, I can put it in my calculator. Here. Let's say do 0.25 miles plus 12.4 miles plus 3.1 miles. So that many miles in that many minutes. Huh? Wait, I think JP is on the right track. Guys, if you're driving a car, or give me like I'm driving 1.1 miles per minute. I'm driving 0.21 miles per minute. Miles per hour. Miles per hour. Miles per hour. So guys, let's convert this to hours. I'll do it right here. Are there 60 minutes and 1 hour? Okay. So let's scroll up to my math here. I'm going to scroll over. I don't want to divide by 75. I want to divide by open parenthesis 75 on 60, right? Because now I have it in terms of hours, so miles per hour, right? You guys got that? Right. So that is 12.6 miles per hour. Right? And the number they're looking for is 12.6. So if you wrote 12.6, that's what they're looking for. And then you would also bubble in 1, 2, and then the decimal, and then a 6. Okay. All right, you guys can do that? All right, you guys good? All right, let's go on to these research presentations.